Hello everyone and welcome back to Python lessons on Codecademy. So today we're continuing on with the topic on bitwise operations. So let's get started. Slide to the left, slide to the right. The next two operations we are going to talk about are the left and right shift bitwise operators. These operators work by shifting the bits of a number over by a designated number of slots. The block below shows how these operators work on the bit level. Note that in the diagram the shift is always a positive integer. So, okay. I'm not sure, but maybe if you use a negative integer with a left bit shift operator is going to do a right bit shift operator with the absolute value of that. Maybe, just a guess. Or it might just return an error. Okay, so this operation is mathematically equivalent to floor dividing and multiplying by 2 respectively for every time you shift, but it's often easier just to think of it as shifting all the 1s and 0s left or right by the specified number of slots and removing or adding 0s in the slots that you've left. Note that you can only do bitwise operations on an integer. Trying to do them on strings or floats will result in nonsensical output. Shift the variable shift right to the right twice and shift the variable shift left to the left twice. Try to guess what the printed output will be. So let's do this. Shift right equals shift right shifted to the right, and then shift left, we need to shift it to the left. So let's see what they actually are right now. So if we shift this to the right twice, it's going to be the ones are going to be shifted to the right, so we get 0, 0, 1, 1 or 1, 1, which is 3. So this should print out OB11 or OB0011, but I think it's going to print out OB11, and if that was an integer it would print out 3. Then we have shift left by 2, so the one is going to get shifted to the left by 2, so we're going to get OB100. So let's see what happens, and that is what happens because we shift the 1 from this twice to the left, so 1, 2, and we get 100. So let's move on. A bit of this and that. The bitwise AND operator compares two numbers on a bit level and returns a number where the bits of that number are turned on if the corresponding bits of both numbers are 1. For example, 42 and 15 returns 10. So I will explain it in how it works after I explain this. So if you have 0 and 0, you get 0. We've worked on how operators work, logic operators work before, so this should be something familiar. So 0 and 0 is 0, 0 and 1 is again 0, because both have to be true to return a true. Then you have 1 and 0 is 0, and finally 1 and 1 is 1. So if we know this, then you go through each column and just apply those rules. So 0 and 1 returns 0 because you're comparing those two. Then you have 1 and 1, it returns 1 because both are true. Then you have 0 and 1, it returns 0. 1 and 1 again, it returns 1. 0 and 0, it returns 0. 1 and 0 returns 0. And then those also return 0 because they're all zeros. So as you can see, the 2's bit and the 8's bit are only bits that are in both A and B, so A and B only contains those bits. Note that using the AND operator can only result in a number that is less than or equal to the smaller of two values. So remember, for every given bit in A and B, that's true. Therefore, binary of 7 and binary of 10 is binary 2, as it says there. So we need to print out the result of calling binary on 0b110 and the binary of that's 5, I think, 101. So what that's going to return should be binary 101, I believe. No, binary 100, which is equal to 4. Yes, as we can see, it returns binary of 4, because when you compare 1 and 0, you have 0. Then you compare 0 and 1, you have 0. Then you compare 1 and 1, you have 1. And the 0, which you can add here, it's if you add it, or if you don't have it, it's the same as having it. So here I can add as many zeros as I want, I still have the exact same number. So 0 and 1 is 0. And the same is for there, you can add the 0 there, and it's a 0. So let's move on. A bit of this or that. So the bitwise OR operator compares two numbers on a bit level and returns a number where the bits of that number are turned on if either of the corresponding bits of either numbers are 1. So I will do the same as the AND operator. We can look at this before that. We've covered logic gates before, so this should be simple and familiar. So 0 or 0 is 0 because both inputs are false. 0 or 1 is 1. 1 or 0 is 1. 1 or 1 is 1. Now that we know that, we can compare the columns. So we get 0 or 1 is 1. 1 or 1 is 1. 0 or 1 is 1. 1 or 1 is 1. 0 or 0 is 0, and so on. I think you get it. Hopefully. If you don't get it, then just ask in the comments. It should be simple to explain. Meaning that binary 6 and or binary 10 equals binary 14. Instructions. For practice, print out the result of using OR on binary is that 15, I think, and binary 5 as a binary string. Try to do it in your own without using the OR operator if you can help it. So we need to print out the binary of it. Or do we need the integer? I don't know. Let's just do this simply by doing 0b, and then I will by using the operator, and then I will explain how it actually does it. And 101. So let's save and submit. Oops, this needs to be binary. So we get the result of 15. Oh, that's actually 14, and we're comparing it to 4. So we're comparing 1 or 0, and we get a 1. 0 or 1, we get a 1. 1 or 1, we get another 1, and 0 or 1, we get another 1. So yeah, I think that's again pretty simple. So let's move on. This XOR that. The XOR or exclusive OR operator compares two numbers on a bit level and returns a number where the bits of that number are turned on if either of the corresponding bits of the two numbers are 1 but not both. So let's look at the table. I don't think we've actually covered the XOR logic operator, so this might be a bit new. So we have 0 XOR 0, it's 0 because both inputs are off. That's the same in an OR, in a normal non-exclusive OR. Then you have 0 XOR 1 is 1, again normal. 1 XOR 0 is 1, again normal, but then you have 1 XOR 1 is 0. This is because it's exclusive and it has to be OR. So if both of them are on, it returns a false. So the binary of 42 XOR 15 returns binary of 37. So let's see why this is. You have 0 XOR 1 is 1. 1 XOR 1 is 0 because XOR, if both inputs are the same, then XOR returns false or 0. Then 0 XOR 1 is 1. 1 XOR 1 is 0, and so on. So keep in mind that if a bit is off in both numbers, it stays off in the result. Know that XORing a number with itself will always result in 0. So therefore, binary of 7 XOR binary of 10 returns binary of 13. For practice, print the result of using XOR on those numbers and those binary numbers. So that's the XOR, so we have 0B1110 XOR 0B101. So let's see what it returns, and it returns binary 1011. And let's explain this again. So we have 1 XOR 0 returns 1, 0 XOR 1 returns 1, 1 XOR 1 returns 0, which is where we get that 0 from, because it's an XOR, and it works differently from OR, as I explained previously. And then we have 0 XOR 1, and we get a 1. So let's move on. See, this is not that hard. Actually, it is. Well, it depends on your understanding. The bitwise not operator, or I think that's tilde, I'm not sure, just flips all of the bits in a single number. What this actually means to the computer is actually very complicated, so we're not going to get into it, unluckily. Just know that mathematically this is equivalent to adding 1 to the number and then making it negative. And with that, you've seen all of the basic bitwise operators. We'll see what we can do with these in the next section. I actually wonder what's going to happen if we make that negative 42. Does it add 1 or take away 1? It adds 1 and then times -1. So what it does is +1, and what the result of that is times by -1. And that's the most explanation that I can actually give you, because I myself don't actually know how it works. So thanks for watching this video. If you have any questions on how any of this works, except for the NOT gate, or the bitwise NOT, then please do ask in the comments. Otherwise, please like, share and subscribe, or dislike if you didn't like the video, and tell me why I didn't like it so that I can improve for next time. So until next time, thanks for watching and goodbye.